Hello, Algebra 1, and welcome to Lesson 2.24. The topic is solutions to systems of inequalities in two variables. The goal is to be able to write a system of inequalities and graph and find the solution. So we've graphed inequalities before with two variables, and now we're doing a system. So just like we did with solving equations, we solve systems where there's more than one equation with more than one variable. We're going to have more than one inequality with more than one variable. And this silly riddle to start with is just a way of getting us back in the habit of writing systems of equations. So in this riddle here, we're told, here's the riddle. I'm thinking of two numbers that add up to 5, 6, 7, 8. The difference between them is 9, 8, 7, 6. What are the two numbers? So there's two pieces of information we have. We know that they add up to 5, 6, 7, 8, and the difference is 9, 8, 7, 6. I know there's a decimal there, but it's just easy to say. So if I pick my numbers to be x and y, they add up to 5.678. The difference, think subtraction, is 9876. Now, if you want to type this into Desmos, you can quickly find out what the solution is, and feel free to do that. But I'm actually going to do this one out because if you recognize the way it's set up, we could probably just use elimination here. If I add these two equations together, the y's are going to cancel out, and I'm going to be left with 2x equals, if I add 5.678 plus 9.876, I think you get 15.554. And then if I divide both sides by 2, you get x is 7.777. Lucky number 7. Cool. That allows us to actually find the x value in the solution. I know it doesn't tell us the y value, but it gets us partially there. To find the y value, I can just substitute 7.777 back into one of the equations. And so if I do it to the top equation, instead of x plus y, I'm going to write 7.77 plus y equals 5.678. Subtract 7.77 on both sides. So then y is going to be negative 2 points. Let's see here. $5.678 minus 7.777, negative 2.099. All right, and there's my solution. Now the purpose of this was just to get you back to writing systems of equations, because we're going to need to do that when we're working with systems of inequalities. All right, now we're going to jump down to 24.2, a quilting project. Now in the quilting project, let's see what's going on. To make a quilter is buying fabric in two colors, light and dark. He needs at least 9.5 yards of fabric total. The light costs $9 a yard, the dark costs $13 a yard, and the quilter can spend up to $110 in fabric. So there's two kind of constraints going on here. We have the length constraint, we need at least 9.5 yards, and we have the cost constraint, we need to spend no more than $110. So if you look at the two graphs below, each one of them is measuring one of the constraints. Now the first one looks like this is the length constraint, and the reason why I say that is because we were told that we need at least 9.5 yards of fabric, and I'm looking at my intercepts here, and it looks like the intercepts are right at 9.5, 9.5, which makes sense. If you had 9.5 yards of dark fabric and 0 yards of light fabric, that would be right on the boundary line. And again, we need at least 9.5 yards, so I know that it's going to be shaded above in the length constraint, and I can spend up to $110 on fabric, so that is a situation where I would be shooting below the line, because that's my cost constraint. I can't go over that value, where I need at least 9.5 yards in the length. So, inequality to represent the, let's go down here. Write an inequality to represent the length constraint. Let x represent the yards of light fabric, and y is going to represent represent the yards of dark fabric. So we know that the total has to be over 9.5. So if I just do x plus y, light plus dark, that has to be greater than or equal to 9.5. So which one of these are going to be solutions to it? Well, we can just add them up. X plus y, 5 plus 5 in this case is 10. That's over 9.5. You betcha that's a solution. 2.5 plus 4.5, that's 7. That's not a solution, and that's not greater than, that's not 9.5 or more. 7.5 and 3.5, that's 11. That's definitely bigger than 9.5. You betcha. And 12 plus 10, holy moly, that's certainly bigger than 9.5. Both of those numbers together or separately are bigger than 9.5. When you add them up, that's going to be certainly enough yards for your quilting project. So, alternatively, if I wanted to look at the graph here, the 0.55 is going to be right around here, which just clears the line. 10 just clears 9.5 yards. 2.5, 4.5. So if it was 2, 2.5, 4.5 is going to be somewhere around here. That's certainly under the amount that you need, so it's not going to be a solution. That agrees with what we said. 7.5, 3.5 should be a solution. And if I go 7.5, 3.5, that's going to be somewhere around here, which again is in the shaded region. And 12, 10, boy, oh boy, is that in the shaded region. That is certainly a solution to that first inequality. Now, number 3 here, inequality represent the cost constraint. Now, in the cost constraint, we know that the light cost $9 a yard, the dark color costs $13 a yard, and we got to spend no more than $110. So it's $9 for each yard of light fabric. So 9x, that's going to tell me how much I'm spending on just the light fabric, plus $13 a yard of dark fabric times y yards of dark fabric. That's how much I'm spending on the dark. That can't go over my budget of 110, so that has to be less than or equal to 110. So that is my cost constraint inequality. Select all pairs that satisfy the constraints. Now I could plug these into my inequality just like I did above. If it's $9 times 1 yard, that's $9. If it's $13 times 1 yard of dark, that's 13. If I add those up, that's certainly going to be under 110. That's going to be $22. So that will be a solution because it's less than 22. Now, I'm not going to do the arithmetic for all of these. I'm just going to look at my graph over here on the right. So the 0.11 is right here. That's in my shaded region. That's going to be a solution. The 0.45 is right around here. That's in my shaded region. That's going to be a solution. The 0.83, 83, if 83 looks very close. So I'm not sure. I'm actually going to have to do the calculation here. So I'm going to use my equation right up here. It's $9 for each yard of light fabric, and this 8 represents the amount of light fabric that I'm buying. And then I'm going to add the $13 for each yard of dark fabric times the 3 yards that I'm buying here. And let's see if this is within our $110 budget. It is just over budget. So no. That is just over our budget. And then, so this was a no. Must have been just above the line. And this last one, 10 comma 1. If I go, here's 10. 10 1 is going to be right around here. That is a solution. That's a yes. So that's how we can use the graph to determine what's a solution. Now the 0.22 is a solution for the cost constraint, but not the length constraint. And you can see that 2,2 is in the shaded region here. That's gonna cost you much less than $110, but the 0.22 is only going to give you a total of 4 yards of fabric. It's not enough fabric. That's not enough fabric if we need at least 9.5 yards. But it isn't within the budget. All right, now we want to find a pair of points that is a solution to both constraints. So can we find a combination that gives us the 9.5 yards that we need and gives us, allows us to be within our budget of 9.5 yards? So if you would like to give that a try on your own, give that a try. I'm going to give an answer in about a second or two, but try to think about that on your own quietly. I'll give you guys about 30 seconds. Now I'm going to come up with a solution, but the solutions that you could have come up with, you'll have to check if they're right because there's many solutions to the situation. Now my strategy here is I'm going to kind of put these graphs together. So I'm going to put my length graph on top of my cost constraint graph. So right here is 9.5, and then right here is about 9.5. If I were to connect these lines, my length constraint was shaped above the line. So any point that's above my green line would be a solution to the length constraint, but I need to be in the blue area to be in the cost constraint. So this triangle right here, any point in here will be a solution. So any point that you pick in there are going to be one of the solutions. So for example, this point right here, let's say 8, 2, I bet that's going to be a solution to both inequalities. Now 8 plus 2 is 10, which does meet my length constraint. That has to be at least 9.5. And for my cost constraint, remember it's $9 for each yard of light fabric. So 9 times 8. And it's $13 for each yard of dark fabric, 13 times 2. And that gives us $98, which is within our $110 budget. So that is a solution to the inequality. Anyways, that's the first part of this lesson. Make sure to like, share, and subscribe. If you like my content and you want to see more about it, consider joining me on Patreon and smash the bell for notifications.